Alright, now we're going to use the last number feature that we learned about, which was multiples, to find the lowest common multiple, which is something that you would use in fractions very often. So there are three methods that I'm going to show you to solve the problem of finding the lowest common multiple, and that is listing the multiples, prime factorization, and a ladder method. Now, the listing multiples method is the longest and the ladder method is the shortest. I'm going to show you some very simple examples with each of them, and I'm going to show you only two complex examples with the last two methods, because if I do the first method, you would understand why it would be problematic. So I'm going to show you the first example for the listing method, which is finding the LCM of 12 and 18. Now, you can start from the lowest multiple, which is negative whatever, or you can start from 0, or you can just simply start from the number that you're given, which is 12. So we can start from 12 and list the multiples. We can first start off by listing the first 5 multiples. We have 12, 24, 36, 48, and 60. And then we can just list multiples of 18 up until the point that we either find a matching multiple, or we pass the limit of the multiples we list here, and then we just keep switching until we find the answer. So we have here, it's 18, 36, and then right away you can see you find a match. So the LCM of 12 and 18 is just simply 36. Now let's look at the prime factorization method. We are going to solve the same problem, 12 and 18. To solve this problem, we just simply list prime factors of 12. So we have 2, 2, 3, and then we have 2, 3, 3. And we group all the numbers as we group all the common numbers together. So I'm just going to draw an extra column, put here, and this is all the prime factors for 12 and 18. Then we just simply treat the common groups as 1. So this here is 2 by 2 by 3 by 3, and we are able to get 36. Now, this method seems very easy, but it can become very cumbersome when you have to switch around these numbers to make it simpler for you to see. And I'm going to do another example just so you can see what I'm talking about. I'm going to work out the LCM of 20, 25, 35, and 45. All right. Now, this here is where it starts getting a little bit cumbersome and tricky. I'll show you. So first off, we list the prime factors of 20. We have 2, and then we have 2, and then we have 5. Then I'm going to list the prime factors of 25. We have 5, and we have 5. Then 35, we have 5, and then we have 7. Then 45, we have 3 by 3 by 5. And now I'm going to have to just shift these numbers because it doesn't belong where it is. 5, 7. And this is where the tedious part comes in, which is just shifting around the numbers so you can see what is in common. So we have 2 here, 2 here, 3 here, 3 here, 5 for this group, then 5, then 7. Then we just simply multiply all of these to get our answer. And that is the LCM of these numbers. When you do this last method, it is much simpler to do. You just keep dividing until you find no more in common to divide by. So let's look at the 12 and 18 example that we did in the previous two. So dividing by 2, we have 6 and we have 9 dividing by 3, we have 2, and then we have 3. And then all I have to do is just simply take the 2, multiply by 3, multiply by 2, multiply by 3. This pair here comes from the divisors, and this pair here come from the results, and we get an answer of 36. If I do the same thing as the previous prime factorization example and I solve the LCM of 20, 25, 35, and 45, it also becomes much simpler, much faster. We divide this by a common 5, and we notice we have 4 here, 5 here, 7 here, 9 here. And then all we do is we take the 5 from the divisor, and then we take the 4, the 5, the 7, and the 9 from the result. We get 6,300. And it was much faster than the previous two methods. The last thing I would like to show you is how to find the LCM on your calculator. So this is an example of a calculator that you would be allowed to work with in your exam. The model is a ELW531TH. It's a Sharp, and you can just use the LCM function. So for example, we can say 12, second function, LCM 18, and we get the LCM 36. Similarly to the long example, we have 20, LCM 25, LCM 35, LCM 45, and you get 6,300.